Pantothenic acid's role synthesizing coenzyme A makes it critical for autophagy in tissues where lipid metabolism predominates. During autophagy, cells break down components and need CoA-dependent beta oxidation to generate ATP for running autophagy machinery. This makes B5 especially important for liver and muscle autophagy and during fasting when fat becomes the primary fuel. The mechanism involves B5 as the precursor to coenzyme A, which is central to fatty acid oxidation. When cells break down damaged organelles and proteins through autophagy, they must process the resulting lipids. Beta oxidation requires CoA to break down fatty acids into acetyl-CoA, which then enters the citric acid cycle generating ADP. Without adequate B5, this process becomes rate-limiting. Ranking B5 sources reveals beef liver at 8.3 mg per 3 ounces as the richest source. Shiitake mushrooms provide 2.6 mg per cup cooked. Avocado contains 2 mg. Chicken breast offers 1.3 mg. Egg yolk provides 0.9 mg. These amounts exceed the adequate intake of 5 mg daily with modest consumption. The increased requirements during fasting or ketogenic diets reflect elevated CoA demand. When carbohydrates are restricted, fat oxidation increases dramatically. This metabolic shift requires more CoA to process the increased fatty acid flux. People following ketogenic diets or intermittent fasting protocols may benefit from higher B5 intake. The synergy with other B vitamins creates integrated metabolic function. B2, riboflavin, is required for fatty acid metabolism. B3 is needed for NAD+ in beta oxidation. The B vitamins work as a complex in energy metabolism, with deficiency in any one vitamin compromising the entire system. Protocols combining B5-rich foods with intermittent fasting enhance autophagy through metabolic switching. Consuming avocado, eggs, and mushrooms during eating windows provides B5, while fasting periods trigger autophagy. The B5 ensures cells can process the lipids released during autophagic breakdown. The ketone production connection matters for brain health. When fatty acids are oxidized using CoA, excess acetyl-CoA converts to ketones. Ketones provide brain fuel and activate their own signaling pathways, including potential autophagy enhancement. Adequate B5 supports this ketone production during fasting or ketosis. For liver autophagy specifically, B5 becomes critical because the liver is the metabolic hub for fatty acid oxidation. Liver cells constantly process fats, requiring abundant CoA. When liver autophagy clears damaged organelles rich in lipids, B5, dependent CoA is essential for processing these lipids into usable energy. The deficiency of pantothenic acid is rare because it's widely available in foods. The name pantothenic comes from Greek meaning from everywhere. But marginal insufficiency might occur with poor diet quality or increased demands from fasting or ketogenic approaches without attention to B5 intake. My assessment is that vitamin B5 fuels lipid-based autophagy through coenzyme A synthesis essential for fatty acid oxidation. Ensuring adequate intake from liver, mushrooms, avocado, and eggs, with potential increased consumption during fasting or ketogenic protocols, supports the energy production necessary for autophagy machinery, especially in liver and muscle, where lipid metabolism predominates.